Usually. So if I'm looking at a few of these, to remind ourselves of how it works with the calculator, what you wind up with is some value. What angle has a cosine value of 3/5? Your calculator at that point in time finds you the angle within the first quadrant. I believe it comes out at 0.98, somewhere along those lines, or 9.3, I think. What is it? Is it 9.3? Yep. So that gives you the reference angle of 0.93 in terms of radian, whatever that fraction is. Okay. From there, you need to figure out where else is cosine positive. Well, cosine is also positive in the fourth quadrant. So your two angles are going to be, well, 0.93, and the other one's going to be whatever 2 pi is, minus the 0.93. Okay. Now I asked that you guys put all of these into general solutions. So are those two angles the same distance apart going back and forth to each other? No. So that means you just tack on your plus 2 pi n, and that's what it was. Okay. I think there was another one that had a tangent like that also. Is that right? We want to be the tangent 1/2, I think. Is it that one? So obviously, if you see something like this on a test and you don't have a calculator, are you going to be able to do this?
Yes.
No.
No.
You can try.
No, probably not. So let's go through a couple of ones that I thought that were a little bit trickier. For example, 37. We have 2 cosine squared minus sine of x minus 1 is 0. You can't solve them when you have both cosine squared and a sine value, but what this is forcing you to do is to use the Pythagorean identity to rewrite cosine squared, because you can rewrite that in terms of sines. So remember, Pythagorean identity says that sine squared plus cosine squared is 1. So therefore, if I move the sine over, I get 1 minus sine squared is cosine squared. This is where those Pythagorean identities come into play. Distribute. Gonna have to factor it because it's a quadratic. But I want to factor with the leading term positive. So I'm going to move everything from the left to the right. I'm basically just changing all the signs. But what's 2 minus 1? 1. So when I rewrite this, I get 2 sine squared x, excuse me, minus sine of x, thank you, minus 1. I was getting ahead of myself. Now, did you guys use that use substitution stuff, or did you just factor the way it was sitting? You can use it either way. What times what's negative 2 you add together to get positive 1? 2 and negative 1. So we have 2 sine squared x minus 1 sine x plus 2 sine x minus 1. And this is where I go looking for GCFs. I usually do this when I have minus and a plus. I put the subtraction one first so I don't mess up a sign. No, it doesn't. Take out a sign. Take out a 1. Out of the two things in parentheses, the same thing. Set them both equal to 0 then. So we have 2 sine x minus 1 is 0, and then we have sine x plus 1 is also 0. What angle has a sine value of 1/2, and what angle has a sine value of negative 1? Sine of 1/2, I believe, is my 30-degree angle, so it's my pi over 6. Where is sine positive in which two quadrants?
Just kidding.
1 and
3. No, 4. No, 2.
you'd get there eventually. So pi over 6, 5 pi over 6. To each of those, what do you have to add on to it?
2 pi.
Is your 2 pi n. And then sine is -1. Where is your y value -1?
3 pi over 2.
3 pi over 2. And those are your three values.
Why'd you add 2 pi in again?
Get to -1, gotta go all the way back around to get to -1. All the way back around to get to -1. General solution.
Oh, general.
Okay. Hmm? What's that? Oh, sorry. I make a better door than a window. That's wrong. Right, you quit my day job. 38. What can't you do on 38?
Anything.
I can't divide. I have to subtract. I can't divide.
No, I mean, like, you can't subtract and then it becomes cosine squared.
Oh, yeah. Okay, I see where you're going. So this one here, you have to subtract the cosine x. And now you take out your GCF. So where's 0 and where's the plus or minus 1 for these? Do not divide by cosine. If you do that, you eliminate solution. Okay.
I like to eliminate solutions. Less work.
I'm wrong, we're wrong. Just go with me, right?
Did you guys catch the trick in the inverse one?
No.
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 Yeah, but see, Ryan, you wrote some problems.
Secant squared is the inverse of what trig function?
Secant, cosecant.
Flip it.
He's going wrong. He's in
So you flip it. You flip it and you go from there. So what angle has a cosine value of plus or minus 1 over root 2? Is it okay that I don't rationalize? The 45s? Now the 45s, when I'm hitting plus or minus root 2, that's going to be all of the 45s. Please don't pop it up. So it's your pi over 4.
We're talking about what? Did you just do something or were you talking about that? You said please don't do something. Were you talking about this or did you just...
He said, don't pop it down.
Oh, okay. I got so offended because he said please don't do something. I was like, whoa, what?
Anyway, so you're at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Is there a constant change between all of those? How much? Pi over 2. So your answer would be pi over 4 plus pi over 2 n. And you said you went into tangent?
No.
Could you?
Cosine? Well, yeah.
I'm sorry, secant squared. Secant squared is tangent minus 1, right? So, or no, not tangent squared minus, what's tangent squared?
No, sin squared plus 1 plus
Yes. So if you switch secant squared to tangent squared plus 1, you'd get tangent squared equals 1. And tangent squared tangent then equals plus or minus 1. what angle has a tangent of plus or minus 1? All your 45s. You get the same exact result. Okay? And that's the idea. By using some of the identities, you can go either direction. Personally, when I see reciprocal stuff, I just flip it, because if you flip the fraction, it's just as fast. Okay?
When we flip the 2 pi n.
I didn't flip the 2 pi n. What I did there is going from 45 to 135 to whatever. Pi over 4, to 3 pi over 4, 5 pi over 4, 7 pi over 4, they're all pi over 2 away from one another.
Right.
That's why.
So, if you actually just found all the answers all for the quadrants, could you do that instead of writing plus?
It depends on how it's asked. If it's asked on the interval, then you list all possible. If it says general, that's when you do that. Okay? That's a big question that comes up all the time. If it says list all on the interval, you list them all. If it says general, then you have to have some sort of a pi n or whatever in there.
But list all, you wouldn't have the pi n.
Correct. Correct. Okay. You have to use an identity here as well. Secant is the reciprocal of what? Cosine. Cosine. What's sine of x times 1 over cosine of x? Subtract it over. And then you go through the roll of factors. This is we're solving.
Okay. Oh, so you're solving for x.
Yeah. Okay. Take the tangent out. Buy dinner. Maybe some pie.
I got it.
Hey, is today Pi Day?
Yes. And a little while ago, it was 3.14159.
Oh, yeah. Well, last year was 3.14159.
Throughout the entire school day without knowing you were fighting, that's crazy.
Yeah, last year was like pi joke 1592.
So you have what angles have a tangent of 0 and what angle has a tangent of 1. Tangent being 0, that means it's y over x. That means x is 1 or negative 1, y is 0. Where does that happen? 0 and pi. 0 and pi. And then the other one would be, where is tangent equal to 1? Pi over 4. Now, where else is tangent positive? Third quadrant. Are those two the same distance apart from one another?
Yeah.
Yeah. So that's when you tack on just the pi n.
That's that stuff from Friday.
Yes. From a lot of last week.
Well, I mean, like that where it's equally distant.
Yes. Yep. Just it. Oh, that's right. That's why you were doing it this way. Yeah, because when you still multiply by cosine, you get sine over cosine, which is tangent, whereas tangent equals 1. It's a long way of going about it, but it's just like the idea where you can reset secant squared as one and the same. So it still works. Is the fuzziness of this starting to peel away somewhat?
Nope.
It you have a fuzzy onion, you might want to send it back.
You ever seen one?
That's gonna end up being all of them.
Just eat around.
Just eat around.
That's gonna end up being all over the onions.
Okay. In this one here, we have 2 cosine x equals secant of x. We gotta change it to a cosine, very good. If we change it to a cosine, we wind up with the following. 2 cosine x equals 1 over cosine x. If I subtract it, I get equals 0. That doesn't get me anywhere. But if I multiply it, what happens here, guys, this is a trick that happens quite often. Whenever you have reciprocal properties on both sides of the equation, a lot of times, if there's nothing else tacked onto it, a lot of times it's wanting you to write it in one of the bases and just multiply it by, you did?
Yeah, that worked out the answer.
Well, I didn't flex.
No, you did it here.
Just keep going, just keep going.
Anyway, so what happens here is you're moving it over by multiplying. So you get 1. And you get 2 cosine squared. So x is going to equal the inverse cosine plus or minus 1 over root 2. Are you guys okay with me shorthanding just right to the answer?
Yeah, that's fine.
Yeah, sure.
Sir. All right. So what gives me cosines of 1/2?
45.
45. Stop being so stupid.
How about some more support? Be supportive of your friend.
No, he's been a jerk to me all year.
No, that's a lie.
The candor. We get that again.
Wait, this is plus or minus.
Yeah.
It's all horrible. That's how I wrote it out.
Wait, that's all.
Because it's plus or minus 1 over root 2, so it's plus or minus root 2 over 2. So you have all 4 45-degree angles.
That's
Yeah.
when you need to
From what? What happens when you have the pi over 4s? If I start here, if I add 90 degrees, I get here. If I add 90 degrees, I get here. If I add 90 degrees, I get here. So every time I add pi over 4, I'm at a spot. I don't have to worry about that the other round with that 3 pi over 2. I don't have to do those. Not 3 pi over 4.
What if you add it plus?
This is the most general way to do it. Because it's the more simplistic way to write it out. It's kind of like simplifying fractions all the
Well,
way.
like I wrote.
Okay. What's happening there is you told me you gave me this angle, this angle, this angle, this angle. The other one is 3 pi over 2? That's not even one of the angles.
So it's pi over 2 and.
All right. Guys, come on. Mr. Williams. Once again, set aside equal to 0. Move the right to the left. And then you'll wind up with 2 terms that happen to share something in common. Cosine x, cosecant squared x, minus 4 cosine x. What do they have in common? Cosine. Yeah. Factor it out.
I thought it was plus for a second there.
Set them both equal to 0. Angle has a cosine of 0. Okay. Obviously, we'll go back and rewrite that in a second. But then the other one. Cosecant squared x minus 4 is 0. So you get cosecant squared x equals 4. Square root it, or should we flip it first? Flip it. Cosecant squared flipped is sine squared. So you wind up square root of 4?
I didn't meant to say it too.
When I flip it, I get 1/4 on the other side. By taking the reciprocal on both sides, you get that. So now you take your square root, what angle has a sine of plus or minus 1 over, excuse me, 1/2. It's your 30 degrees. It's your pi over 6. It's all 4 of the reference angles that contain pi over 6. So this one is going to be at pi over 2 plus pi n. The other one, though, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. The pi over 6 and 7 pi over 6 are the same distance away from one another. They're pi away from each other. Okay. So that one we can write as just a plus pi n. Don't need that. Same thing with the 5/6. Don't need that.
Could you say 11/6 plus pi?
Instead of the 5/6? Yes.
Wait, what is it, say, what number of rotations?
Yes, sir.
Why is it higher and not 2 pi?
Going from pi over 2 to 3 pi over 2.
It's pi.
It's pi apart. Yes, ma'am.
You're looking at something that's 2 plus 2 pi. No, you just have like 1 back
Yeah, or you could still have it with 2 dots. Let's say you have 2 cosine. You just have a cosine of something, where you get like pi over 3 and 2 pi over 3. So you have the positive and the negative, that's it. But you don't have to worry. Or 2 positives or 2 negatives, something along those lines. When you have square root stuff, you'll wind up with 4. But when you have not square root ones, you should only get 2. I got a couple extra ones here for you. I would do a couple of them off of here that deal with more reciprocals and things. What's that? I think I lost count. Oh well.
I'm used to them being handed out one.
What the heck, I just do that. It's much easier. Hey, I don't want to look at. So I'm going to look at number 9 on the B side. Oh, you don't.
Oh.
Somebody else not have a, somebody have a, only have a B side?
I got B and A.
Oh, I don't have a
There you go. Oh, you guys found the originals. No, I'm just
Are
gonna do a
there
couple
any
of these.
answers on it?
No. So, here's what goes. With this one here again, we gotta get a side equal to 0. Now, one of the things I can do is move the 3 cosecant over by subtraction. But then I'd have 2 different negative values on the left. So why not move the left to the right? Okay? Move it, both things on the left to the right, it just works out to be a little bit cleaner. So you get 0 equals cosecant of x plus root 2 cosine x cosecant x. Oh, doesn't equal 0 twice.
Got rid of a 2 in there.
I subtracted it over.
Oh,
Okay.
oh.
I subtracted it over, combined them like over. Okay. Should. I'm joking.
I know you are.
So what do we have in common?
Cosine, or cosecant.
Cosecant. Factor out the cosecant. Do I have 2 terms that equal to 0 then? Set them both equal to 0. Cosecant is the inverse of what trig function? Sine. So if I inverse both sides, careful. If I inverse both sides here, I get sine of x would equal 1 over 0, which is undefined. Do we ever get a sine value that's undefined? No. So will that side work?
No.
So no solution on this side.
Next
Okay.
problem.
So the other part is worried about. Okay.
Next problem.
So now it's 0 and 1.
On the other one, all I have to do is subtract 1 and divide by the root 2.
Oh, and that gives you 45.
So what angle gives you the cosine of negative 1 over root 2? It's a negative. So it's negative cosine, so that's second and third quadrant. So that's going to be our 3 pi over 4, 5 pi over 4. This is your example of when you're only going to have 2 solutions. You only have the 2 solutions there because cosine is negative here and here at those 2 values. Those 2 values aren't equidistant going both ways around, so we just have to tack on the 2 pi n. Okay. Yes, ma'am.
So I understand why it's pi and pi over 2 and because I don't understand why it's 2 pi. That's just the same.
Every time you go around one full revolution from that point, you're going to wind up back at that point. That means it's every one of those angles. Every one of those coterminal angles will have the same cosine value. That's all it means.
If it's negative, wouldn't it be in both negative?
It is. That's why I have two different angles.
So you can't just leave it at that angle?
No, because there's two different angles to give you that negative cosine. So the other thing I was showing the other class was why that sine value doesn't work like that. And this is going to come into play later on this week, if not into next. When you look at the graph, when you look at a unit circle and you look at your y values, sine of 0 starts at 0. At 90 degrees it goes to 1. At pi it goes back to 0. At negative 3 pi over 2 it's negative 1, and then it comes back up to 0. So it oscillates through. It does this. Whereas cosecant inverses all of it. So the inverse of 0 is undefined. Okay? The inverse of 0 is undefined, so that's why I put a vertical asymptote there. What's the inverse of 0 again? Undefined. What's the inverse of 0? Undefined. Now, what's the inverse, the reciprocal of 1? 1. What's the reciprocal of negative 1? Okay. Along the way, the value of sine becomes a half at pi over 6. And at 5 pi over 6, it's 1/2. What's the reciprocal of 1/2? 2. And then it'd be at negative 2. Cosecant graphs blow up. Will cosecant graph ever equal 0? No. That's why, because sine graph is never undefined. Since sine is never undefined, cosecant's never going to equal 0. That's how these things work. They just blow up from one another by using the reciprocal properties. And we look at it at your pi over 6, your pi over 3 if you're looking for the other stuff and going through there. Okay? That's why that happens. It's kind of cool. It says the math teacher.
Did it know it was pi day?
I knew it was pi day. Let's see, what was the other one I wanted to show you? Number 5.
Still empty.
Yeah. 2 cotangent to the 4th of x minus cotangent squared of x minus 15. Remember what the rules were when you had upper or higher degree polynomials? If there were still 3 terms, the degrees were getting cut in half. Factor it normally. Factor it just like you would before. Okay. But what I'm going to do here, just to make it look a little bit cleaner, I'm going to use that u substitution again, just to make our lives easier. All right. So I'm going to let u equal cotangent of x. So 2 u to the 4th minus u squared minus 15 is 0. What times what then is negative 30? They add to get to negative 1, you get negative 6 and 5. And Shimke, this is why I put that negative 1 first. That was just easier. I don't have to worry about factoring out that negative twice. That's all. And I just root everything. It's up a bit. And I put back the cotangent now that I'm done factoring. Are we okay with that? Subtract 5, divide by 2. If I square root that, what happens? And I have imaginary trig values.
No.
It's a no good part. Okay, that's not going to work. Can you only imagine if we had imaginary trig values? That'd be great. Thinking about it right now. That was bad.
Just keep your day job.
Yeah, please.
Why is it imaginary?
What happens if you take a square root of a negative?
Imaginary.
You can get an I, but we don't have imaginary tricks.
Okay.
And then on the other side here, you get tangent squared would be bless you, would be 1/3. I reciprocal and move it over. Yes, sir. I doubt it. I don't think it exists. It might. And then obviously, when you do plus minus 1 over root 3, it's pretty quick for doing the tangent. I just wanted to show you that you not have to worry about negative radius. I reciprocated it right away. I added the 3 and took the reciprocal because it was cotangent squared.
cotangent.
Yeah. So I did it that way real fast, and then you just work from there. So on this one here, on the A side, no, you still got to do the tangent. It's, you know, what gives you tangent plus minus 1 over root 3. It's what, pi over 6? Do those sets, please.
So would it just be like pi over 6 plus pi n? Would it also be just like 7 pi over 6?
Oh, to finish that one out, here, we'll go back and finish it. If I go back to finish this one out, I have, this will be what angle has a tangent value of plus or minus 1 over root 3. So that'll give me, that's my pi over 6. Be pi over 6 plus pi n. That takes care of first and third quadrant. 5 pi over 6 plus pi n. Now, like Bella was asking, could you have written 11 pi over 6 plus pi n? That's fine, but it's more accustomed to go as you're going around the circle like you would normally, adding degree value, adding radian value. That's all. It's just pinky up type thing. Yes, ma'am.
Like, I know how you got all 4 of those answers, like the pi over pi n. But how do you know the pi over 6 isn't 2 pi?
What do you mean?
Like, why isn't it pi over 6 plus 2 pi n? Or pi over 6?
If you're at pi over 6, and the other one was 7 pi over 6, to get from here to here, to get here to here is, to here to here is, here to here is, that's all it is.
I know, but for the other answers, like, so is it if you just have one answer, then you put 2 pi n for that?
It depends on what the angle is and what trig function is with. There's no, you can't pigeonhole it into something perfect every time. All right? Tangent values generally give you the pi n of anything, whether it's positive or negative. Sine and cosine is just one value, is usually 2 pi n, because if you're looking for a sine value that's positive, you're just up here. If you're looking for a cosine value that you're positive, you're here and here. But if you're looking for all 4 of them, then you tack it on, they can be from here to here, drop them back around. Okay. So it depends on what trig function as well as what sine, S-I-G-N, you're looking to find.
Like, I understand that, but like,
Yes?
and I think how come you don't know that there's 2 types?
Because this was just what angle has cosine of negative. There's only 2 of them. This one was what angle has plus or minus for 3. You're going to get a minimum of 2 answers. So if you have plus minus, you have 4 possible angles. If it's just no plus minus, it's just one angle with 2 spots.
So you end up only getting one answer, but you add stuff to my answer that goes on.
Louis, what do you got?
Actually, is this like, are we going over these or are we working on it?